Did you guys drink taste good?
Oh, mine's delicious. Mine's delicious. I'm having to like make sure I don't just sit here and drink it because it's like I'm a little thirsty.
I'm not sure mine tastes that great.
With your cabbage in it, probably like your cabbage cocktail.
It might be the cabbage. Who knows?
Welcome back to Chemists in the Kitchen. Today we are talking about color, and we're gonna have lots of fun making cocktails that have all sorts of different colors to them. And then we get to drink them, and you get to watch us.
I can't top that. Let's just leave it at that. My name is Adrian. I'm a physical chemist, and I work for a medical device company.
I'm Joan, and I am a conservation scientist in Washington, D.C.
My name is Matt, and I'm a chemistry professor at American University in Washington, D.C.
So, Joan, this is your idea, talking about pigments and color. So tell us what you thought about a set of experiments where we can learn about chemistry here.
Something that I find really interesting about the world around us is color. And I thought that talking about the colors in food would be really interesting because there's some really great chemistry there. For tens of thousands of years, people have dug things out of the ground or picked pretty colored plants and used molecules from those materials to create something that is aesthetically pleasing. We're going to get to play around today a little bit with making a colorful extract from a natural flower, and we'll be extracting the color parts of that flowers. We sometimes call that the chromophore. And then we're going to be able to make a simple syrup using that extract and use that in different drinks, in different beverages.
That's the next question is what kind of experiments are we going to do today?
What are we even doing here today?
Yes.
Yeah, so
what are we doing?
We are going to be using butterfly pea flowers, and they are native to Southeast Asia, I believe. And so in the recent years, these have become kind of a fun ingredient to use in many different recipes because of the color changes we're going to be playing with today. They're dried, so they're all shriveled up, but they're kind of these pretty blue-purple petals, and so we're going to extract the color from the flowers and put it into a simple syrup. It is a 1-to-1 ratio by volume of sugar and water. And you just dissolve that in there, usually with a little bit of heat, and then you have your simple syrup. We're just going to add the butterfly pea flowers or powder to that so we get a beautiful color.
Actually, it went pretty fast, by the way, so pretty immediate. So I already had boiled the sugar, so it was already warm. And so as many as I put the flowers in there, the extraction happened pretty much instantaneously.
So the dye molecules that we're extracting from the butterfly pea powder today, or flowers, today are called anthocyanins. And I made my own visual aids today. I'm very proud of myself. So anthocyanins are really common in different flowers and fruits and vegetables. But then I've marked all of these places around the perimeter of the molecule with these blue kind of X's. And that's where the variability comes in. We call a methoxy group. It's an oxygen bonded to a carbon that's bonded to 3 hydrogens. That's one option. And then the other option is an OH group. We sometimes call that a hydroxyl group. And that's the one that I think we're going to be playing around with here. Matt, do you want to tell us more about what can happen with those OH groups?
Right, it's the OH group of an acid. So a carbon double bond to an oxygen, single bond to the OH, right? The hydrogens want to stay on that molecule because there's too many other ones in solution, so they stay on that molecule. But if you change the pH, if you bring the pH up from something acidic to something closer to neutral, right? That proton then says, oh, there's fewer protons around. I'm just going to pop off and go hang around in the water. And when it leaves the molecule, that molecule is left with a negative charge. And so in doing that, you change the way that molecule interacts with light. And light will interact with that molecule differently depending on whether that proton is on and it doesn't have a charge, or if it's off and it's negatively charged.
Maybe we should try the cocktail part to really hammer
It
this.
is just like a shut up.
What are you making? What are you both making today? I want to hear what you're making.
Oh, God, I don't know.
You're still trying to. Joan, what are you making?
I decided to keep things very simple today. I am going to be making a classic Tom Collins cocktail. So that will involve our prepared simple syrup. That's this beautiful, again, it's actually so dark you can't really tell what color it is, but it's this beautiful blue color. I will be using gin and sparkling water. And then I'll be adding some lemon juice to see if the acidic lemon juice changes the color, so we can watch that. That's what I'm hoping. You can just simply leave the gin out if you don't want to have any alcohol in it.
I did make the simple syrup with the pea flowers, but I think red cabbages also has anthocyanins in it. Is that the way I'm pronouncing it right?
Yeah. Yep.
Anthocyanins. So anthocyanins are probably something much deadlier, so who knows? Anthocyanins. So.
Matt, what are you going to be making?
Today I am making a shrub, and a shrub is a vinegar-based drink. And so my shrub, I started making it earlier today, and here's the base that I've got for it. So this is apple cider vinegar and grapefruit. So I bought a grapefruit today and I juiced it, and it also has some grapefruit zest in it and Szechuan peppercorns that I steeped with sugar for a while just to extract some of the flavors. And then to this I added some of my the pea flour. All right, so already we've got a big color change here, right? So this is the color it normally was. So I'm just gonna be adding either tonic water or club soda to this to sort of dilute it a little bit, add a little extra fizz, and make a good flavor. So let's do this in order of pH. So this is low pH, this is neutral pH, and then here we go. I'm gonna add my pea flour syrup into my into my baking soda filled cup here, and
You're decanting.
All right, there we go.
Yeah.
Oh, nice.
Both of these are just water now, right? So water and water. So I'm just gonna add some of the syrup to that, just so we can kind of see how those colors differ.
Such a pretty blue.
It is a very pretty blue. All right, so I'm gonna add acid to this one.
Ooh.
There we go. Hold on, let me give it a little bit of a
see it.
stir here. I can add some more.
Love it.
Ha
Oh, they're really good.
Ah,
Fantastic.
there we go.
That is the color change we're gonna be seeing in our drinks.
Okay, so I'll go ahead and I've got a glass with ice in it. I'll go ahead and again, I chose to use gin for this cocktail. I have that, and then I will add my simple syrup. Okay, so it's this pretty, really gorgeous sort of blue-purple color. I am gonna first add a little bit of sparkling water, give some fizz. And also we'll probably notice a slight color change here a little bit, I'm expecting. Maybe, I don't know. Because carbonated water is ever so slightly acidic. It is not neutral, because when you dissolve carbon dioxide in water, you make carbonic acids. Let's see what happens once I add the lemon juice. And I've got 1 ounce of lemon juice here. I'm hoping this is cool, but we don't know until we see.
Ooh, very pretty. Yeah.
There it is.
Ooh.
Yeah.
Very happy with that.
Looks delicious.
This should be a nice, refreshing summer drink to have on this rather humid day. So I might just taste that.
So I know we've been talking about pea flour, but we had a version of this, and I'll try the cabbage stuff. We don't know how it's gonna taste, but I think I wanted to hit home the effect of what the effect color is.
Yeah,
so.
I feel like I do taste the butterfly pea powder a little bit. Again, there's a little bit of a floral note to it. It's very subtle. I don't think it's a strong flavor.
I put that in there. So that's the original color that I have here. Okay, so that's the purple cabbage kind of. Oh, see, that already changed its color.
Ooh,
So you can definitely see the color change.
Cabbage is, a leaf, right? Versus a flower on this butterfly pea flower. So they're using them probably for slightly different reasons. Again, either attracting pollinators, giving them some amount of protection from some environmental stress. There's just different reasons why these plants would use these different molecules. So you get slight variations, but they're all in that same sort of class of molecules that we call anthocyanins.
I mean, did you guys taste does your drink taste good?
Oh, mine's delicious. Mine's delicious. I'm having to like make sure I don't just sit here and drink it because it's like I'm a little thirsty when talking and stuff. It's like probably don't want to just down that. So
yeah. I'm not sure mine tastes that great.
With your cabbage in it, probably like your cabbage cocktail.
It might be the cabbage. Who knows?
I'm gonna try to layer this to see if I can get.
Oh yeah, you want to do that experiment?
I love this.
Yeah.
Let's see.
Okay. All right. So there we go. Now add a little bit of lime juice. Start to see
I
it.
can see the top looks a little.
Add a little bit
that's
more.
Awesome.
Slowly, so it stays on top as much as possible.
There you go.
Yeah. Yeah. No, that's awesome.
I think as a wrap up, right? I think where we really started was trying to explain at a molecular level the chemistry around color, right? It's more than chemistry, right? There is the physics involved, right? The chemistry in terms of how protons are adding and changing the structure, and then the physics about like how light is interacting with matter and how the response occurs as a result of the proton exchange between the molecules that we're dealing with.
This was a very fun kind of experimental episode, and it just kind of reminds us that it's not magic, it is science, it is chemistry, but the feeling of that magic and that exploration is, I think, probably what drew a lot of us to chemistry and why we do what we do. But it's a way to just see how the world works, but is amazing. And color is one of those things that I think humans are naturally drawn to. And so absolutely, get out there, get in your kitchen, get out in your yard. If you have some flowers, grind them up, mix them up, see what happens, make some things, make some mistakes. Maybe don't eat everything.
With a caveat. God.
They're gonna roll a disclaimer at the end of this.
Yes.
It's gonna be like,
Joan said I could eat this.
Otherwise,
also...
how do we learn, people? How do we learn?
And if you are enjoying what you're watching today, hit that like button, smash that subscribe button, watch more on LabX.
Yeah, thanks everybody for coming in to join us in the kitchen and have some fun experimentation with pH and some dye molecules and getting to explore kind of the colors in the world around us and also make some tasty, refreshing beverages. So hopefully you'll join us again next time on Chemists in the Kitchen.
Cheers to that.
Cheers.
Cheers to that.